There's a very important tool in algebra, and it's called, oops, I need to be writing here, the zero product principle. And it says the following. If A and B are real numbers, and A times B equals 0, then I can conclude that A equals 0 or B equals 0. Of course, that being the mathematical inclusive or both. Okay. If you have a product of two real numbers and that product is equal to 0, then one of those numbers had to be 0. That's the only way that I can get 0 for my product. So let me show you a quick example of how that's useful. Let's say I want to solve this equation, 8 minus x times 2x plus 3 equals 0. I know from the zero product principle that since this times that is 0, either x minus 8 equals 0 or 2x plus 3 equals 0. Right? Whatever real number I get when I substitute the value in there for x, if I have their product as 0, then one is 0 or the other is 0, or both, which won't happen here because x would have to be two things at once. But let's solve these now nice linear equations. X minus 8 equals 0, add 8 to both sides. So here x is 8, 2x plus 3 equals 0. Let's subtract 3 from both sides. That gives me 2x plus 3 minus 3 is 2x. 0 minus 3 is negative 3. Divide both sides by 2 to get the 1 on my x. Gives me, I'm writing in blue for some reason, x equals negative 3 halves. So this equation has two answers. X could either be 8 or x could be negative 3 halves, and they're both solutions to that equation. Okay, the zero product principle allows me to solve that equation without too much hassle. I just need to set each factor equal to 0 and then solve the resulting linear equations.